You are alone in a continent, I suppose.
Yeah, more or less.
Yeah. Welcome. This is the audience of...
The nearest man from here.
Yeah. Because probably Italian board teachers already know very well who you are and your activities, but a general introduction is more than welcome.
Yeah, okay, of course. I can start with myself. I am Simone Chiccarella, the station leader for the winter, and I am an electronic engineer in charge of nine different experiments. Experiments related to geomagnetism, seismology, ionospheric interaction with electromagnetic waves, and more than this. I don't want to bother you, but more or less I cover all these materials related with electronics and the Earth. Of course, I'm not the only one with experiments. I have a lot of colleagues. More or less, we have all the scientific stuff today, and also one of the best technicians we have. So I'll give the microphone to each one, and he can present himself to you.
Hello everybody, my name is Paul Serre. I am a chemical engineer and the French glaciologist of the station. I am in charge of 5 glaciologist program and 1 astronomy program with Carol.
Hello, I'm Laura. I'm an atmospheric chemist and a glaciologist for the Italian part. I follow 4 projects related to the atmospheric chemistry and the glaciology part. And I follow also an instrument that is in collaboration with ESA and is for monitoring the polar cap.
Can you hear us?
Yes.
Okay. Hi, I'm Alfonso. I'm in charge of the meteo station, the meteorological balloon, the measure of solar radiation, and in the winter of the LIDAR.
Hi, my name is Carol. In Europe, I'm a doctor specialized in critical care, but here I'm the research doctor for the European Space Agency. I have 3 programs of research on the immune system, on psychology in extreme environments, and on bone and muscle metabolism. I also have some research on cognitive skills. I also work with the plumber. I do the quality analysis on the water recycling unit that we have here. And as Bert said, I contribute a little bit on one of the astronomy programs.
Hi everybody, I'm Yuli. I'm a researcher in the field of computer science and telemetry. And here I'm in charge of the experiments of astronomy, 2 of them. And one is E-rate, and the other one is beta B. And one is about the RGB stars, and the other one is about the exoplanet trend.
Good morning to all of you. I am Aldo Clemenza. I am a doctor, a specialist in anesthesiologist and intensive care. I am the medical doctor of the station. My role here is to guarantee the health by prevention and I hope not by therapy.
Hello everyone, I'm Andrea Tosti. I'm a computer engineer and here I am the ICT responsible. So we have to manage the network, the server, the connectivity of the internet and the intranet and all the telecommunication.
Hi, my name is Paul Mouffa. I am the French mechanic of the station, and basically I drive and I maintain a truck type loader to get fresh snow to have some water, some drinking water.
And if you want to know deeply which kind of experiments we conduct here, it's possible for us to explain them, but it could be a really long job. I can say you that today we had a really heavy day because the technical manager has to test some special function of the thermal system and forced us to switch off all the experiments we had. And so we walked a lot because our experiments are really far from the station, sometimes still 2 kilometers far from here, more or less. So we switched off each experiment, and after 4 or 5 hours we switched on again with the problem of the cold, of course. So it was a really dense day, but if you want to know something specific about experiment, we are here. If you are interested, we can explain in a better way which kind of experiment we do about glacial part, I have to say, and I can pass you Paul, or if you have some specific question, we are here for that.
I'm trying to talk on behalf of the audience, and this is a meeting, a workshop of educators and teachers, and we are interested in know general aim and objective of main scientific experiment you are carrying on. And later on we have some questions to pose about education activity, if you don't mind.
Okay, no, of course. Yeah, I can start to say you that essentially we collect data for different kind of matters and interest and science and subjects. For example, I manage a network of seismic sensors that are directly connected with the Europe and that are used to understand how the earthquakes propagates on the surface and inside the earth. So our experiments unique, how to say, isolated, because we are the only one with this sensor here in Antarctica, in the dome. And so these data are really rare and precious. And same things for, how to say, atmospheric, ionospheric electromagnetic waves propagation. So a lot of experiments really specific, really unique in the world, of course. Maybe Laura can give some details about her experiments and why these experiments are important.
So for the atmospheric part, here is very important to collect data. So I have some instruments to collect aerosol samples. And here is very important to have a data set long enough, minimum 30 years, to understand the future, so what we will expect from the global warming and so on. But it is also important to connect this data with the ice core drilled here in Antarctica, for example, for Epica ice core that was drilled here in Dome Sea. So Concordia Don't See is very important because, as Simone said, is a unique place, is a remote place. So we have almost clear air without contamination, and yeah, we are far away from the industrial part of the earth, without pollution, exactly. And yeah, and also we can connect with all the ice core that here in Antarctica are drilled. I have also other experiment like cosmic ray experiment, and we want to see if this cosmic ray that arrives here can modify the aerosol particles that are here. And also this experiment is important to do here because we are very near to the geomagnetical field pole, and so here is the unique part that we can conduct this experiment. And as I said before, I follow also this instrument that is very similar to the instruments installed on the satellites, and we can compare the data collected here with these instruments in the satellites to have a validation. And I also do every month a snow pit to measure temperature, hardness of the snow, and density, and then we compare this data with the instrument that is here, with also the instrument in the satellites. So after that we can use the satellite to have measurements also in the other part of the Earth. So here we can validate this instrument. And yes, then I also follow another experiment where I measure and I observe the precipitation every day, and I collect samples for a group who will analyze them for the isotopical part. And also this is very important to understand the air masses that arrive from normally from the Southern Ocean, and we also compare this data with some instruments that measure temperature and the cloud covers with the radiometers.
About the French programs, so I have 5 programs. The first is a CESOA program. We collect some gas and aerosols, and we analyze this by ionic chromatography. So we do this about 10 years. So we have a lot of data that we do a bit every month with Flora. We collect a lot of samples. We have the night DC program. We study the ozone concentration and the nitrogen oxide concentration in the snow and in the atmosphere. So we have a lot of instruments for this. There is the Gemostral program for the study of the mercury concentration in the atmosphere. We have also the NIVO program with a lot of instruments like the laser scan to study the surface of the snow, some albedo measurement. We study the temperature in the snow every 10 minutes with a lot of sensors. And there is also the CALVA program for the meteorological observation. We are very lucky here to have the American Tower with a height of 45 meters, and we have a lot of sensors for the temperature, pressure, humidity, wind direction, wind speed, like this, at a lot of stage. So it is very good and very unique in Antarctica. It's okay.
So essentially, each of us has to follow several experiments and has to collect data or samples that are sent to the Europe, French or Italy or somewhere else, and that are elaborated by our principal investigators. So we can't elaborate the data directly here because we don't have the structures to do this. But we need to collect every day this data, trying to lose less quantity possible of them.
Yeah, we have some question. There is another explanation. Okay, Luis, do you want to come here and pose directly the question?
Hi, I have a question for you. Did you lose a lot of data by having to turn your sensors off for 4 hours? Does that concern you in your research?
Essentially, we try to collect data 365 days per year, but sometimes we are forced to lose data because we have technical trouble to manage. And here it's not simple to fight with problems because the really low temperature that here are more or less around minus 80 degrees now in these days. With these temperatures, the instrumentations are really critical and problematic. So we try to preserve all the data we can, but sometimes we are forced to lose data. For example, today with the thermal test, we lose more or less 4 hours of our data, and this could be a little problem for us, but we were forced, so it was impossible to avoid this kind of problem.
Here we have an atmosphere very strange. We have low pressure and low humidity. So here our instruments are very often they can break. So sometimes we lose a lot of data. Some blackouts that can occur with electricity can cause these breaks. So for example, this morning we switched off all the instrument because we wanted to avoid these problems. I had one PI who asked me to try to lose as less data as possible. So I switch off the instrument, then after a couple of hours I switch on it, and then I switch off again. So I went up and down every couple of hours to try to lose as less of data as possible. But we prefer to switch off the instruments when we have these problems, because if we break the instrument, it's worse.
Questions?
So are you able to transmit a lot of your data to other parts of the world from where you are?
Yes, of course. We use a very small antenna technology to send data all over the world. It's the same channel we are using now for the Skype conference. The channel is, I would say, is capable to transmit data, scientific data, and human data. I would say internet connection and phone connections, Skypes, and so on. So we use this satellite to transmit data. But sometimes we have some trouble with the satellites because there is no propagation from our antenna that anyway is working at minus 80 degrees, so it has some problem itself. And we can store the data inside our server for several days and transmit this data when possible to have a link with the satellite on California. So this is the link we use mostly. For emergency purpose, we can use another kind of satellite communication, but we are not using now in these days because the VSAT is working perfectly, and so we hope to have this link for the rest of our winter, for the rest of our 9 months, more or less. Yeah.
I just wanted to add, I think it's an interesting question you ask, because as Simone is explaining, I wouldn't say that data transmission is a limiting factor here. It doesn't limit any of the things that we do, but it's definitely a huge constraint because we can't send big amounts of data at the same time. We have to partition everything, and I think it's extremely time-consuming for all of us because we have to chunk up all the data, send it every day, check whether it's been sent. When it hasn't, try again. So yeah, it is a huge constraint on us.
May I ask you something about the biomedical research? What are you investigating and who are your subjects? Human subjects.
So I'm doing research for the European Space Agency. It's interested in Concordia because this is what's called a space analog. So the conditions we live in are actually very similar to those in which astronauts going to Mars would be in. We're completely isolated, even if there's a medical emergency. So a plane can't land here, it's too cold. And we're also going to have 3 months of complete polar night, which makes it even harder for a plane to eventually land here. It's obviously extremely cold, things can go very bad very quickly. There's a lack of oxygen. There's the fact that this is a multicultural team, that we didn't know each other before coming here and that we have to get along and work together. So these are all conditions similar to what astronauts would live in. The research I'm doing, the biggest one is on the immune system, because previous research in the past years has shown that our defense mechanisms are actually altered and we fight less well against viruses, for example. And that would obviously be a huge problem if astronauts get to Mars and once they get there they all fall sick. So now we're looking into the mechanisms of this altered immune system. I'm doing research on early detection of depression by analysis of voice, of speech. We have to do little 5-minute diaries every week, and a computer basically analyzes our tone of speech, how quickly we speak, whether we use different words or not. And then the third research is linked to the fact that we obviously don't walk as much here. We're quite limited around the base. As Simone said, the furthest we can go out is 2 kilometers. We also won't have any sunlight for 3 months, so we might be lacking vitamin D. We eat differently. We don't eat fresh fruit, fresh vegetables. So there can be alterations in our bones and our muscles. So I'm doing scans and various blood samples for that. And basically the volunteers is absolutely everyone, including me. So everyone's very nice and is giving up some of their time to give blood samples and to do various tests. And I've also had to learn to do blood tests on myself, which is not the best part of my job. Urine samples, also stool samples, hair samples. I have a lot of different tests for all of my lovely colleagues.
Beautiful.
Bonjour. Buongiorno.
Buongiorno.
Buongiorno, everyone.
Bonjour.
Yeah, okay. I think for this type of audience, one of my general questions that I think would be very important to do, particularly from an Antarctic Treaty perspective, you have 3 flags, but I'm sure you collaborate with a wide range of countries, and most of your projects are probably major European or world monitoring programs. Can you get a little bit into it to show that Antarctica is actually quite international and multidisciplinary?
We didn't understand really clearly the question because there was a problem with the audio.
Okay, which countries do you work with other than those 3? There's 3 flags.
No, 2 flags.
No, there's Belgium or...
Belgium. No.
So most of my research has been approved by the European Space Agency, which puts out, I think every 4 or 5 years, offers to accept projects. Most of the teams are actually, like you said, multinational. So there are hospitals in Germany, but they work with teams in Belgium, in France, even in the United States. The psychological program is from Hungary and also a Canadian doctor. So it's definitely very multinational for ESA.
My solar radiation measurement are a part of a project, a bigger project. It is the BILSARAN. That is the measure of solar radiation around the world, and many countries participate in this project, like Italy. But the project itself is not from Italy; it's a bigger project. I think from Germany, but I'm not sure. And also some of the aerosol measurement me and Laura makes are from Finland, and these are my international projects.
My projects are principally Italian, but they have collaboration with other countries. For example, the cosmic ray experiments is from University of Oulu in Finland. Then the project of the DOMEX, the instrument for the analysis of the polar cap, is from Italy, but is a collaboration with ESA and also with the University of America and the University in Spain.
The most of my projects are French, from the Grenoble to the Laboratory of Glaciology, but we collaborate with other countries. And for example, for the mercury analysis here, this is a global observatory on the Earth, like in every part in the world. So this is data not just for us.
I have, for example, Super Darn, that is a special radar for ionospheric convection of the air. That is a project that belongs to the world, because every nation has his radar on the Antarctic region and on the North Pole. So we have a lot of experiments that are involved in many countries.
We have another question here was, what kind of hardships have you faced already?
A lot of problems. I don't know how to start, but we also had during the summer, for example, a colleague that broke his leg simply because he was connecting one shelter to the base with an optical fiber. And we had trouble with pumps, for example, that doesn't work with the cold and that stuck with the lack of humidity we have here. I had some trouble with a lot of antennas I have in Superdan, for example. And so we can have a lot of different kind of problems, starting from the medical one to the really high technology one. For example, the computers that doesn't want to work with us sometimes and stops their programs without any reason. And so we have to understand why these scripts made in maybe in Linux or in Bash, it depends, are.
Yeah, today I had some problem with the meteorological balloon because my implementation of the thing that does the ground check of the sound broke, so I had to replace it, and there were problems with the connection and things like that. This is the kind of problem that makes like the measurement delay, and then this is not good because it has to be done at a specific hour and things like that.
I think definitely at the beginning, I think not a single one of my experiments ran smoothly. It took a lot of patience. You don't really expect that when you get here. You're really motivated, you want things to go. I think there's also the problem when we land with the altitude of feeling quite fuzzy for about 2 or 3 weeks, I think, all of us. And you kind of think, am I this stupid, and am I going to stay like this for the whole year? It's really, really scary at the beginning. There's the fact that I think most of us can say we don't sleep well at all here. It's a problem that's very well recognized throughout Antarctica. It's not very well understood. There's the cold, there's the rhythm, sun and night, there's the altitude, the lack of oxygen, the dryness, but it's, again, not completely understood, and it's definitely a huge problem because it can really ruin your days. Today, I think Paul was telling me a huge problem we had with some of our computers in the shelters is that one of the radiators wasn't working, so the screens stopped working, and then you think, is it the computer that's burnt? In the end, it was only a screen problem. There's also travel. I think we don't think about it as much now during the winter, but in the summer it was a huge problem trying to plan for the flights. They would either be held at the coast because of bad weather, or couldn't stop on the way here to refuel because of bad weather at midpoint, or they couldn't land here because of poor visibility. And so I think absolutely every single plane was delayed, sometimes by up to a week and a half. And then that caused other problems, for example, getting the injured out, or getting our fresh food in. I think our fresh food arrived with 3 weeks of delay, so it wasn't that fresh anymore. So yeah, that's it for us. And then I think Bud can maybe say a few things about his machines and the cold. Yeah. Nope, sorry.
So, after this list of things, my question is, why you get there? I'm sorry, but everybody... It's such a special place, but there are special places in Italy too. So.
Yeah, but they are not the same over here, of course. It's like to be astronaut here. And you can see special landscape that in Italy we don't have, or maybe we don't have in other places of the world. You can live with a, how to say, in really special condition. You have to simply walk with a temperature around minus 100 degrees that are with the wind chill, of course, that are really strange for us. If I ask you, can you figure out, can you think how is your life with minus 100 degrees? And it's not with wind chill. It's not simple to answer if you don't come here. So that's why I'm here. I wanted to discover these new things about the world. Maybe also the doctor has something there.
I think for me it's obviously the challenge and thinking that not many people kind of get the chance to come here. I think I didn't realize until I got the letter telling me they accepted me, and then I kind of thought, okay, I can't say no to this. How many people get this chance? And then it's obviously for me because I've had the dream of being an astronaut forever, and it was a chance to work for ESA. But yeah, that's it.
For me, for example, I want to wonder of everything in my life, and this is the wonder and wonder and wonder that I can try.
For me, it was as Carol said, it was a big challenge, and it is a way to do my job in a very special way, in a very different way. So I learned my job, but with a very new experience, and it's very interesting.
For me, this is to be like on the moon or another planet, so I like it.
More questions? I have one final question related to education. You are committed in having video conferences and with a lot of institutions and schools, and we really appreciate your efforts in having this since a long time. And my question is, how many hours per week you devote to this activity, and if there is a sort of assessment related the impact of these actions in outreach?
Okay, how many hours per week? It depends on the week, of course, and on the month. Mostly we have conferences with schools and with institutions, like you said. We have more or less 2 conferences per week, so that means 2 hours per week. But we also have test contacts and mail dialogues with these institutions. So more or less we have, let's say, 3 hours per week, even because we don't have too much time to reserve to the conference, because we have to think on the experiments. And the second part of the question, I forgot. Yeah, of course. There's a sort of survey that usually INEA sends to the institution to understand which kind of impact we have on the institutions, and if the conference was good or not for a different point of view, like connection, topics, questions, and so on. So if you can kindly send to us your how to say, impressions, we were really happy. Yeah.
I just wanted to add that next to these official conferences, I think we are, almost all of us also have individual projects with kind of our families and close friends. For example, last week we had a conference with a French school from Didier, our technical chief. I'm trying to organize something with my niece in Canada, and obviously we feel very much probably more invested in these ones because it's kids that we know and we want to transmit something to them, and that definitely taking a very, very long time. But I hope it's worth it if we can try and motivate these kids to see that science can be passion, and that there are so many things out there, so many work experiences that they can look forward to.
Okay, thanks a lot indeed, and it was simply amazing. There was a silence in the hall and everybody was staring at the screen, and we are really amazed by you, by your explanation, and for a while we have been there with you. And thanks indeed. I'm sure that this kind of experience are going to motivate us even in working hard and involve and motivate students and other teachers in these kind of topics. Thanks a lot from all of us, from our president and all the audience, including Dave Carson, Director of World Climate Research Program, and Jenny Baseman, Director of the SCAR, that is here with us in Rovereto.
Is there anything I can do for you?
And for instance? We are going to publish all our presentation on our website, and we are going to share this link with you to have a glimpse of what is going on here in Rovereto in these days. Thanks indeed again to all of you.
Okay. Thank you again.
Grazie.
Thank you. Thank you.
Very cool.
I have a couple of warnings. One is for the field trip of tomorrow.